Nehrkorn. I'm the Director of Digital Consulting at SICK. In the digital consulting team, we handle a lot of the complex applications for safety and for robotics and for AMRs, which is obviously a new emerging field that for the last 3 or 4 years has been really starting to accelerate. We're going to talk about some safety standards today that have come about because of that interest in that area, for sure. I've been with SICK about 9 years. I've been doing machine safety specifically for about 35 years, right? So I have a lot of experience in designing electrical control systems for safety, both microprocessor-based control systems and automation for machines, including safety, of course. And currently functional safety expert for SICK. I actually teach the functional safety courses that SICK offers for those who want to become a functional safety engineer who do nothing but safety, a lot. So without any further ado, let's take a look at the agenda. We have an action-packed hour and a half. We're going to kind of set the stage a little bit, kind of give a foundational baseline because I'm not sure where everybody's level is on safety. So we'll go through our philosophy real quick of the 6 steps to a safe machine. Then we'll talk a little bit about regulations and requirements both in the US and the EU, just to kind of level set of why we're a little bit different, because our standards then have to adapt, of course, to our view of how we look at machine safety in North America, specifically the United States. So we'll look at the legal framework. We'll talk a little bit about OSHA, and that usually is some very interesting conversations there. But more importantly, we're going to take some time and we're going to look at these new standards that are relevant, probably have been either updated, revised, or published in the last couple of years that are very interesting, of course, around robotics, mobile robotics, and industrial robotics. And some of the standards that support general safety also that bolt on, shall we say, to those environments and to those needs for safety around there. So that's what we're going to try to get through today. SICK has a philosophy, it's kind of based a little bit on the machinery directive in Europe. We've adopted this philosophy of how we look at machines. And you can do this as an OEM, right? This is definitely an OEM-centric viewpoint. But if you're going to revise or update a machine that may or may not be safe, you can use the same strategy for looking at a machine and trying to walk through it in a nice sequential way to do a risk assessment through your design, technical protective measures, and updating the machine. So real quick, let's kind of walk through that, and I'll tell you a little bit about each step. Obviously, you need to know the laws, right, the requirements, and then what standards support your endeavor, right? If you have a robot, what standards should I look at? If I have a general packaging machine, what standards should I be looking at, right? Because they're going to give you guidance on how to achieve a safe machine, whether you're if you're designing, building, or what have you. So once you have your target and you know what some of your requirements are, which we're going to set some more for that today, most of those standards today are calling out to do a risk assessment, right? The machinery directive in Europe, this is a mandatory requirement. We're going to see today in the North American robot standard, this is also a requirement, okay? Risk assessment is nothing more than identifying all of the hazardous situations on a machine and looking at the people, the personnel who are exposed to those hazards when they perform certain tasks, right? And it's important that we do that because sometimes the operator is exposed to things more often and therefore could be at a higher risk to do some activities. So we need to address that maybe differently than the maintenance person who has to occasionally look at the machine or occasionally work on the machine. But we have to make sure that they can do that safely. So we also want to look at how they're accessing different parts of the machine when they have to perform their tasks. This could be the cleaning people, this could be the setup personnel, could be for minor adjustments, could be for production. So you need to look at all those and document the risk. Okay, so that's what we're trying to do during the risk assessment, is saying, okay, if this is the risk of this person doing this task, how do we want to handle that? What's the best way, right? For instance, when you take a robot cell, right? If I need to ensure that people don't get hit by the robot and I'm the operator, and I come in and I operate and I access the robot here, I have a big table maybe between myself and the robot. So I'm not exposed normally to the whole robot, maybe just to the end effector, end of arm tooling, right? Maybe some of the fixturing, if there's clamping and other activities or motion. But the maintenance person may often go through the door and go into the back to do some other function or troubleshooting. And now they are exposed to the full force of the robot. Okay, so there's definitely a difference in risk there to those two people doing and performing their job, right? So you do want to capture that during the risk assessment. Now, once we've identified high risk, medium, and low risk tasks, right, we want to then decide, well, based on that score or that baseline risk, we need to design it out and or guard these hazards appropriately, right, to the level of the risk. So the first step is, can we design it out, right? Can we substitute, can we change the process, can we change the speed, can we change the force? Can we do some things where we can actually just eliminate the hazard or at least reduce it in scope, that it makes it safer? And quite often, maybe there is some gains you can make there, but if a machine's gonna do something, there's probably always going to be some hazards that you just can't eliminate any further, and you need to address them then with technical protective measures. So this is safeguarding. We're going to look at a standard today that covers all of the techniques, right, and a lot of the information about how do I do safeguarding. And if I'm applying guards, if I'm applying presence sensing devices, right, what does all that mean? What are the requirements? What should I do? How should I do it? Right? And what does that look like? That also includes tying these devices into the machine control. So this could be the robot controller, could be the actual safety controller if this has been added on. Maybe if you're doing a retrofit, you may need to then also consider what level performance I need for my circuits and my electrical controls, because I'm trying to mitigate some very high risk activity, motion, and I need to do it at the right level, right? It's not necessarily adequate to put a sign on a machine when somebody could get severely injured, right? So we have to make sure that whatever risk reduction strategy we use, it has to commensurate with the risk, okay? But signage and PPE and training and those things absolutely are important, because they are the additional steps you take to minimize further any risk that's left over, right? There's always going to be risk on a machine. And so yes, I've guarded the machine. Yes, I control the access to the hazardous areas, during the machine motion when the maybe production is taking place, you're reaching in, or you're going in to clean out a jam or pick up something that the robot's dropped, okay? But maybe there's a thermal hazard that maintains itself even after you shut it off. So maybe you do need to either train the people, warn the people, put up signage. These are still residual risks you have to manage, okay? So you do have information for use, you do have signage, you do have awareness means and barriers and other things that also help to reduce the risk. But again, they're no substitute for addressing the highest risk, right? These are for the lowest risk that's left over. So this is called the three-step method, okay? So we design it out, guard it, and apply administrative measures, okay? If you do all three of those things, the goal is that we're gonna slowly reduce the risk down to something that's manageable. Before you put any machine into production, if you've made changes or you're designing and building new machines, you should, and specifically robots, there's actually clause 6 in the North American Robot Standard walks you through all the steps for validation. Okay? You need to validate. You need to make sure that, yes, everything I set out to do in the risk assessment got done. All the guards are in the right places, they're the right size, they're the right shape, right? They're the right height, right? When I access this in this mode of operation, this still works, but that doesn't work, right? All the things I set out to do, we gotta make sure works, okay? Before we turn it over to production, and we now run it off and deploy the machine. So when we deploy the machine, so in North America, right, you're gonna turn it on, you're gonna put it into production, and machines are designed and built and sold, and that's fine. In the EU, however, there's an additional step, right? We're gonna talk a little bit about the machinery directive briefly, but before a machine can be placed in any member state of the EU that is governed by the machinery directive, you are required to self-certify your machine most of the time and sign a declaration of conformity that you're conforming to all of the standards, and we're going to talk about that in a minute. And once you've done that, you apply a CE mark. Then you may sell your machine in the market, okay? And until that time, right, you're not to do that. And if, the regulatory authorities in each member state find out that you're placing machines on the market, whether they're hazardous or they're not compliant, or they have or don't have a CE mark, they're going to actually then say, okay, you need to remove that machine from the market until it's fixed and you've got it properly documented and safe, right? Sometimes that requires additional third parties, sometimes it's self-certifying, right? Depends on the type of machine you have. And if it's super hazardous, those machines are the ones that usually fall into the list where you're going to need a notified body to look at those. It's interesting because robots don't. Robot systems, you might think are super hazardous, and they can be, for sure, but they're not required actually as an integrator to be third-party, reviewed and certified, so to speak, and then declarations of conformity signed by a notified body. So it's interesting, but there are some other hazardous machines that do. And then, last but not least, you need to make sure that the end user has all the information they need to maintain the machine in a safe state and to operate it safely for its given lifetime, right? With all the different things that you identified in the risk assessment. So any information that you need to pass on needs to go in the manual, needs to go into the training material, or whatever you need to give to the end user, okay? And so as a machinery builder or even as a retrofitter, if you say, hey, in this mode of operation, be aware this hazard still exists, you still need to handle that with PPE, because you decided all these things up here, you're not doing anything about them. You don't go with the machine and do that. So you need to pass that on to the end user. And then the end user has to maintain a safe machine, right? Because you're no longer connected to it, so to speak, as maybe the machine builder and the integrator, okay? So that is an overview, quick overview of the 6 steps. So that's our foundation. As I mentioned, at SICK, we follow this, and this is how we approach all of our work whenever we're working with customers and talking with them and navigating what we're going to look at next, which is standardization. And what are the requirements, and again, this pops up over and over and over again. So this is it in a general overview. Any questions about the 6 steps? Make sense? Okay, good. All right, let's talk about laws, directives, and standards, okay? So in any given endeavor, when we go to look at a machine and we head down the path, we need to, again, understand the targets, right? So in North America, we have OSHA. In the EU, they have the Machinery Directive as part of the laws of the member states in the EU. By treaty in the member states, they have their own directives that they need to follow. All of these countries, member countries, can have their own local standards. And they can also adopt as members of ISO, because every member country of ISO will get a vote and can participate in the standardization for ISO. So therefore, a lot of international standards, and you know quite a few of them because a lot of organizations and companies have adopted ISO standards in different parts of their organization. Machine safety is no different. You can actually use ISO standards. We're going to talk about quite a few of them today. But we're also going to talk about a little bit of difference of why they're organized the way they are versus the ones we have organized in the United States. These are ones that fall under the American National Standards, the ANSI standards, because of our legal framework, right? That's always kind of the driver. So we are a member of ISO, so yes, we participate in ISO standards. Currently, SICK around the globe, last I knew, was roughly 20 or so different individuals who serve on standard committees worldwide. Okay, that includes managing a lot of the safety tag committees in Europe for IEC and ISO. In North America, I know we monitor and serve probably on close to 30 standards, give or take. Either we're monitoring them or we're heavily involved in them, depending on the focus and depending on if they're actively being revised or written. I've served on several over my tenure doing machine safety. Quite a few people here locally at SICK also serve on them. The couple of standards I'm going to show you today, we actually have employees at SICK that are actually the chairpersons of those standards. So they're actually driving their development or their revision. In the EU, this is the same, absolutely. So in the EU, real quick, let's level set on what the viewpoint of the EU is. So, as I mentioned, the CE marking is the conformity symbol that says in Europe, you've built a machine according to the machinery directive. This is a requirement. This levels the playing field for all machine builders in the European Union, right? You don't get a separate set of rules, and this is done on purpose, obviously, because otherwise, you can imagine how difficult it would be to build a machine, let's say in Poland, and then try to sell it anywhere else in the EU if everybody had their own rules and laws. And so they said, no, we can't do this. We need to have one level playing field. So what we'll do is we updated the machinery directive, and we said all member states will adopt this. All of them will actually look to the official journal of the EU to find all of the regulatory standards that may be used to make machines safe, right? So if you look at the machinery directive, you look at the document, it tells you, here are all the things you need to do. Not how to do it, just what the results have to be. Then you'll go to all the standards. These are the European norm standards. So you'll see a standard that says EN, like EN ISO 12100. That's a European norm. That standard may be used then to do a risk assessment that complies with the requirements of the machinery directive. Okay? This is the quickest way in Europe that you make a safe machine, is that you follow the European norm. You design your machine according to the norms that fit your machine, and then you can sign your declaration of conformity, you can put your CE mark on it, and you can place it on the market. Okay? Very straightforward for everybody. It is also machine builder centric. This is for machine builders. The focus is on building a safe machine from the beginning. Remember, you can't put it on the market if it's not up to date, state of the art, following the latest safety standards. Okay, so this is where the onus is.
And that's a big change, because it used to be that the end user was responsible for the safety, and OEMs didn't really care. They just put machines out there. I'm talking like 20 years ago. That focus is now shifted back to the OEMs to provide safe machinery.
Yeah, and again, the new standard, the new machinery directive in 2006. This is the new approach. This is the new approach for all member states. Okay, so therefore, as an end user, your requirements come from another directive, the work equipment directive. So now that you own this machine that's CE marked and is safe, you just need to maintain it according to this directive. And there are standards also available to you to say, yes, I will maintain it in a safe state. I will have it inspected regularly. I will have presence sensing devices double checked every once in a while, yearly or every 2 years, based on the requirements of the machine. There's information in here in this directive then of points end users. How do I maintain my safe work environment? Okay, so OEMs, end users, very straightforward. Okay, and this is the way we do that. As I mentioned, in Europe they follow standards, of course, and we do as well, of course. All standards. So let's cover this now so that we can understand that all standards come in about 3 different flavors, right? So we have A-type standards. These are basic standards that are very general, right? They're not specific. They apply to lots of different processes and industries and machines. So like risk assessment, right? General requirements for safety in general for risk assessment is an A-type standard. So we're going to look at B11.0 today. B11.0 is an ANSI standard for North America, and it is an A-type standard. ISO 12100, which is the equivalent ISO risk assessment standard. They are very harmonized. The processes are very, very similar. That is an A-type standard. Okay, general, overall. Oh, sorry. B-type standards. B-type standards come in 2 flavors. We have safety aspects, things like different sources of hazardous energy, how to control it, how to maintain it, ergonomics, temperatures, shock, vibration, electrical issues, right? So lots of standards over here that deal with these types of activities and safety aspects. And then safety devices. So B2 type standards are, how do you design a safety light curtain? How do you design a safety interlock switch? How do you design safeguards or guarding? How do you design, emergency stop? How does it need to be arranged? What does it need to look like? What are the colors, right? Again, general purpose, because these devices are used in a lot of areas, so I need specific standards that tell me this is how we should do this, okay? So those are the B-type standards. C-type then are machine specific. These are experts in this field that have sat down and have written a standard on how a safe X machine should be built, okay? So hopefully those are people from industry that understand how those machines should be built and are actively doing that because you need their knowledge. They're usually pushing the edge of technology, right? Whether it's robotics, or it's packaging machinery, or tractors, whatever it is, right? These are the experts. So they sit on these standards and they write and they tell you, this is what a robot system should look like, because everybody from the robot arena and all those companies are hopefully serving on that standard, and they do. So that gives you a lot of information, and that is very valuable if you're doing the same, right? So as I mentioned in the European directives, okay, the requirements to meet the directives, right, are to everybody in the European Union follows along. And the way they do that is they apply the European standards. As I mentioned, these are the EN standards. These are the European norms, okay? If you go to the official journal, you will find the EN standards that you should look to and apply when you do your machine, okay? It shows a presumption of conformity. It's not legally binding that you absolutely positively have to follow them. But if you choose to go on your own and do your own thing, then the presumption of conformity disappears, and now you are on the hook for proving that the way you did it is as safe as if you just followed the standard, right? So there's no requirement, but it wouldn't be very smart to not use the European norm standards, right? They are state of the art. And obviously most people just follow the standard path, and this makes it nice, okay? So what does that look like? A, B, and C type standards. This is the whole list of the different types of standards that are typically applied. You'll see some of these are ISO, and that's okay. So that means they're international standards. We can use them as well, right? We're a member, we're a voting member. The US is a voting member of ISO. We have lots of people that serve on the ISO tag committees, so they also are monitoring and working actively when these are revised or written. So we have a say-so, right? So therefore, they are absolutely relevant, and you can use them. Maybe they have some more state-of-the-art information. So we have guards, we have interlock devices, right? Now some of these are B1 and some of them are B2 type standards, right? So if it's a device standard, these standards will tell you not only how the device has to be designed and built, but also how it's applied properly, right? Protective devices, presence sensing devices, pressure sensitive or electrosensitive, right? So these are also products, again, that have design standards. Two-in controls, IEC 60204. This applies to the low voltage directive. This gives you all the requirements you need when you wire up and build a machine, including the panels and the cabling and the terminal strips and all that information that you would as an electrical engineer. You would want to understand what's in this standard. The equivalent harmonized standard to this in North America is NFPA 79. For those of you who understand and have a copy of that, these are very much equivalent. Okay, there are a few differences, right? Emergency stops. What should they look like? What colors? How you should apply them? Where they should go? What are the requirements for the circuits? Functional safety in drives. We have safety rated drives now that have all sorts of safety functions for, say, motion control. We'll talk about that because that also found its way into the robot controller, which is a new thing, new in the last 10 years, shall we say, that has allowed us to do some really neat things like collaborative robotics and some collaborative operations that we couldn't do before. And then B1 standards that talk about safety distances, the heights of guards, the openings in guards, where they should be positioned, minimum gaps, those types of things. And then electrical controls, again, how do I do safety-related parts of the control system? So how do I apply these devices, wire them into the control system properly, both for low, medium, and high-risk applications? Do I need the same circuit for this application as I need for this application? Well, your risk assessment is going to tell you what kind of circuit you should be looking at if you're going to mitigate this high-risk activity versus a low-risk activity, okay? So you'll get that information here. ISO 13849 is very, very prevalent right now. Of course, we've been using that since 2012, and it is predominantly some of the best state-of-the-art guidance that you're going to find around safety-related control systems. And other things like hydraulics and pneumatics, other lockout, tagout, or energy isolation and controls, electrical components, those things you'll find in these other standards. So in a C-type standard, like the robot standard, right? Could be we're going to look at a couple C-type standards today in robotics and mobile robotics and industrial robots. I'm also going to look at a couple B-type standards, but C-type standards that are very machine specific, okay? So, any questions on that? So that is kind of a quick overview of the European approach, the machinery directive, and the standards that are harmonized in Europe that actually allows machine builders in Europe to quickly find out what the requirements are to build any given machine and do it safely, okay? Now, what does it look like on our side of the pond, right? So OSHA is our regulatory body, okay? OSHA is the law, and the law says each employer shall furnish a safe place of employment free from known hazards, right? And they need to comply with the OSHA Act, okay? Well, that's the employer, not the machine builder, the employer. So the person who legally is required to provide a safe work environment, including people running safe machines, isn't on the OEM. So this is not the same as it is in Europe. Actually, it's upside down if you think about it. We now have to push the requirement from the end user back up into the OEM. In other words, the OEM will do what they feel is necessary or what they're comfortable with, but there's no regulatory requirement for them to design and build a safe machine before they sell it to you, like they do in Europe, okay? So therefore, you as the end user really have to drive that discussion and say, no, I don't want you selling me an unsafe machine, so I want you to comply with some of the standards we're gonna look at and or ISO standards to ensure that I don't buy an unsafe machine, because in the end, OSHA finds me when somebody gets hurt or they come through my facility and look at my machines. If they're unsafe, they don't come talk to you. I'm the one who has to pay. And I'm the one who legally is obligated to make sure that my environment, work environment is safe for my employees. So therefore, they do this through the general duty clause. The general duty clause in 1910 212 gives them the ability to cite you because you haven't provided a safe work environment. Now, how do they reference these consensus standards then? So why are we talking about standardization if they're only going to cite me because so where does this information come from? OSHA will actually cite you under general duty clause. So they will never walk up and say, oh, you're not complying to the robot standard. They'll say, you don't have a safe workplace under 212, and I'm going to reference a national consensus standard, like an ANSI or maybe CSA in Canada, right? And if you would have just followed that standard, I wouldn't be standing here today giving you a citation because somebody got hurt. That's kind of the underlying tone. So this is always a reactive use, if you will, of the standard by OSHA. Okay, they can't do it everywhere, but they will use this information to help support their case, right? To say, well, you didn't comply to standard X, therefore you have an unsafe work environment. Okay, I'll cite you under the general duty clause. You'll go to appeal it, and if you go to appeal it, they're gonna say, no, there's a standard right here that says if you only do this, you probably wouldn't have had this unsafe machine, right? So they use it to kind of support their citation, right? Even though they didn't purposely reference it as you're being cited to that actual standard. So they will pull them in as a reference, even though they can't specifically cite you for that standard. Some standards are actually called out specifically and referenced in OSHA. If you do find a standard that is specifically in the Code of Federal Regulations, in the normative text, you do have to apply it like law. But there are only a handful of them, and some of those may or may not affect you, but you should always know what those standards are that are actually in OSHA because they carry the weight of law, okay? But things like the robot standard, not mentioned, right? So it doesn't carry the weight of law, so they have to reference it kind of retroactively when there's an accident, right? So when we look at OSHA, OSHA as a government organization, their job is to make workplaces safe. But they also know that there's a lot of low-hanging fruit in some really non-technical areas, shall we say, right? These are fall protection, hazardous communication, scaffolding, ladders. These are general issues, but they're easy to recognize on just about any given day by any OSHA inspector who walks through any facility or construction site, right? It's very, very simple because these are the things that you don't want to make the front page news because they're simple, right? People on construction sites, people in facilities, right? Really, again, it's low-hanging fruit. You don't have the hazardous communication, program. Let me see your training log. Are you training your people, right? Are your fire extinguishers all in the right place? Are they up to date? Are they inspected, right? This is very easy for OSHA to do. As you can see, this is how they kind of orient their thinking. However, even in their top 10, they eventually get to lockout, tagout. I would say this is actually very prevalent for them, especially for machinery, because most accidents happen on machines when somebody is doing something without locking out the machine because it's not a production task, right? They get hurt or injured because they're working on a machine, setting up a machine, adjusting the machine, and they're not following the proper process here by isolating the hazardous energy during that activity. This is only production tasks are allowed with the power on the machine. Production tasks, right? So you need to define what those production tasks are, and then you may have a little discussion with OSHA about, no. You know, if you pick up a wrench and you go in there and you make an adjustment, you know, you're kind of teetering on that gray area. But if that is a normal part of the process and you can do it safely and you can show them that you can do it safely without running over and locking and tagging out every time you need to make this minor adjustment, that might be okay. Like on robot cells, quite often, you'll see a robot who, like a weld cell, right? It'll have a dressing window where the robot will come over and present the torch tip to a window where you can open or look in or reach in, and you can actually see the weld tip and you can do an inspection. That's during production. But there's a method for doing that safely, other than walking through the door, hopefully that the safety system on the door interlock works properly to isolate the robot and hold it steady in a safe position while you go check the torch tip, okay? So there's methodologies for doing that with power on. You can either use alternative measures like the interlock switch on the door, right? Or you can, you know, provide a window, however you want to do it, but those are allowed. Now, if I need to go in and swap out the whole torch tip and I take in my toolbox, yeah, they're probably gonna, you're gonna need to lock out and tag out to do that, okay? That is not a production task, okay? It's beyond on the scope. Quite often, this is where you'll find a lot of issues. Machine guarding, general machine guarding violations here, these are for all the other things that happen, all the other injuries, all the other accidents that happen in and around machines, power transmission, point of operation, right? People reaching in, people getting cut, people, you know, hopefully not getting killed, but it happens for sure. These are issues. So you can see kind of where OSHA thinks. Most of this is reaction, so it's very reactionary, right? It's because there's been an incident or an accident. But if your OSHA 300 log starts to have a few too many recordable accidents, you're probably going to get a visit, right? Otherwise, they only have enough people to go handle, you know, most of the fire calls, right? They don't do a lot of fire prevention. They do some when they can, and if they're doing fire prevention, you may have a visit. Most of the time, that's because somebody complained or has filed a complaint. Maybe a disgruntled employee doesn't think the workplace is safe, and they call the OSHA, and the OSHA says, we better check that out, right? Sometimes that happens too, okay? But as you can see, these are the primary drivers for when it comes to machine safety. They are in the top 10, and yes, it is important to OSHA, right along with the other top things. In most of these, if you've noticed, are all down in 2020. Any idea why that is? COVID, right? So yes, there's less people running around checking up on people. Some facilities obviously were not in full production last year. Some were shut down completely or they went out of business. And like anything else, OSHA is a place of employment, so they didn't necessarily expose their employees as well, right? Certainly during the onset last summer. So a lot of these numbers are down, but they're still there, still working. So what do we have for standardization? So in North America, we talk about standards, right? We have very similar, if not equivalent standards to those ISO, ANSI standards. We're going to look at some, or IEC standards, and we're going to look at some of those. We're going to look at B11.0 for risk assessment, which is harmonized with ISO 12100. We're going to look at the IMS standard a little bit. That is a B11 standard, a machine tool standard for integrated manufacturing systems, also harmonized with ISO 11161. B1119, we're going to look at that one. This is a new one. This is a very nice standard that encompasses a lot of B1 and not too many B2, but B1 standards. And of course, we're going to definitely talk about the R1506. This is the North American Robot Standard, which is an adoption of ISO 10218. So we'll take a look at that. So we do have some of these standards in North America that are aligned, and there's more harmonization all the time. Now there's a difference we're going to take a look at in those standards, and the difference is it addresses this problem that we've outlined, in that the European view is OEM centric, right? It's the machine builder. So there is a regulatory requirement there for the supplier, and that is the machinery directive. The user responsibility for us, however, is OSHA, and in Europe, it's the use of work equipment directive. So again, we have the requirement or the responsibility for a safe work environment a little disconnected. So what we're going to see in general, the IEC and ISO standards are machine builder focused. There isn't a lot of end user information. And that's a problem if you're in North America, where you're an end user and you're trying to make sure you have a safe machine and you'd like some additional information. So therefore, we're going to take a look at how we adapt to that in North America, right? So those standards address that. So before we get into that, any questions?
How often do the standards change?
Great question. Great question. So I know for ANSI, I think you have to, every 5 years, a standard either has to be revised, start a revision process, or be reaffirmed. So if you look at it and say, yeah, it's still pretty good, we don't have any changes to make to it, you can reaffirm it. And you have to come through every 5 years. And sometimes you'll start on a revision, and that revision takes 3 years. And 2 years later, you're looking at it again, do we start another revision, or is it okay for the next 5 years, right? And so the requirements are to keep it fresh, or at least to say, yep, we still stand behind it, this is state of the art, there's nothing new we need to.
How about OSHA standards? How often do they change?
Very, very
Really?
rarely.
Really?
Because it takes an act of Congress.
Right.
So the OSHA requirement came, OSHA Act, right, in 1970 was placed in front of Congress and became law in 71. And at that time, most of the standard requirements that are in there haven't changed since 1971, right? For machine safety, that is true. There's no new standards, there's no new language in any of the machine safety requirements in OSHA. So it's pretty, it's kind of like our Constitution.
It's hard to get, right?
Yeah.
So the issue is that since, the law is kind of stagnant and it stayed, in its pretty much written state, OSHA has the teeth, okay? They have the enforceability ability. What they follow in those instances then is typically what ANSI puts out, okay? So they'll follow the ANSI standards and say, well, you didn't follow this particular standard. Correct me if I'm wrong in saying this. So OSHA really, they don't necessarily write the standards, they write that it's more important to have a safe workplace or for the end user to provide a safe environment for their workers. But, to what standards? And so they don't define that, and they're very vague about that. So they typically follow.
How does ANSI stay up with technology then?
Well, those are the ones that are written by standard development organizations, like the ones we're going to look at are written either by B11 or the Robot Industry Association. They are the secretary of the standard. They manage and write the standard according to ANSI guidelines, so it can be published as an ANSI standard. But they're an industry. They want state-of-the-art guidance for their industry to stay technologically advanced and on the cutting edge. And OSHA's just like, okay, fine, you're the experts, you wrote a nice standard, great. But we're not going to change the law, but you're changing how to meet the law. And hopefully these two always, there is a standard, I don't have it here and don't have time to talk about it today, but lockout tagout, you want to talk about it? Lockout tagout is one of those standards right now that's kind of going through that a little bit.
To your point, the technology often does meet the standards. And so, those groups that get together and write those standards, they're kind of behind, what's actually developed technology-wise, and so they're always catching up to it.
Yep. So let's take a look at some of these standards, the ones that have been revised or updated that are very relevant, right? So we'll look at these three standards, B11.0, B11.19, and B11.20. These are general requirements for risk assessment and risk reduction. And then B11.20, as I mentioned, is integrated manufacturing systems. We'll look at that when we get to the robot side. But so ISO 12100, as I mentioned, is for risk assessment, risk analysis, right, and risk reduction. A new revision was published to ANSI ISO. As you can see, we've adopted it, right? This is an ISO standard, so ANSI has actually adopted ISO 12100, and you can certainly apply that. Specifically, you will apply that if you're an OEM in North America and you're building a machine that you need to CE mark and send to Europe. You'll need to, or want to, right, follow ISO 12100. It is harmonized with B11.0, however, and B11.0 was revised. And the nice thing about it, as I mentioned, is that while they're harmonized and they say and do the same thing when it comes to the risk assessment and the three-step method for risk reduction, but B11.0 goes a little bit further and says, hey, end user, you have requirements too, and we're going to help you with guidance on the three-step method for applying the additional measures for operating and maintaining the machine in a safe way. Because remember, that is the work equipment directive in Europe, and that's OSHA in North America. So B11.0 then puts its arms around the whole environment, machine builder and end user. Okay, so it says the same thing as 12100. It just helps North America with our unique situation, so to speak, right? So this is why B11.0 was updated to harmonize. It was also harmonized with the next standard we're going to look at, which is B11.19, which covers this three-step method, which is, okay, now that I've analyzed the risk, now what do I do? Right? I was like, okay, remember, safe design, technical protective measures, administrative measures. So what does that look like? Well, B11.19 then was aligned with B11.0, completely revised and expanded to have a lot of state-of-the-art information on the three-step method. So inherent safe design, controls, guarding, administrative measures, right? And a bunch of new annexes with all the latest and greatest measurements and information, right? That harmonizes with all of these ISO and IEC standards. And in some cases, we've actually got new information in here that isn't in here yet, but soon will be, right? As these get revised and updated, further harmonization, right? But here's the difference. You can either buy all these for $5,500 on the open market, and this is great if you need to comply. Remember, if I'm building a machine, sending it to Europe, and I need to CE market, I have to make sure I apply this, okay? However, if I'm in North America, and I'm an end user and or a machine builder, I can buy B11.19 for $350. It's 257 pages, and says pretty much everything all these other standards say, and they're relatively the same. Not exactly, but close enough that it makes it easier as a machine builder in North America to try not to have two set of playing rules, right? North American view and the ISO IEC view for Europe, okay? So harmonization of these organizations is getting better all the time, right? The world's getting smaller, as we say. People are working together. We have people that all know each other on both sides, and everybody's trying to work together to try to not only look after their local market, but also to look at the global market, okay? So it is getting better. But the point here is that this is an unbelievable standard you should have. If you're doing safe machine design or retrofitting, absolutely this document is invaluable. B11.0 for the risk assessment and B11.19 for the risk reduction. Okay, so guidance on how to do both, and they're obviously dovetailed together, right? So great documents. They're all new. Yeah, really nice. Any questions? So that was real quick on that part. Let's talk about the robot stuff, because this is really interesting, right? So this isn't so new, right? The RA 1506 isn't really new, but a lot of things that we now have and have further documented to supplement the robot standard are new or newer, and it's getting very interesting, of course, because robots are finding their way into all sorts of non-traditional robot uses, right? Things are kind of exploding, specifically in what we call the logistics automation space, where it's hard to find people to do certain tasks of moving material and equipments and goods. And so both the normal robotics and collaborative robotics space and the mobile robotics space is exploding right now. And so there's a lot of activity going on. So let's take a look at these real quick. So as you can imagine, a lot of traditional, as I mentioned, a lot of traditional applications for robotics. And we have automotive applications, we have machine tending, the gentleman that were here yesterday from Toyota, doing the plastic injection, machinery. They have a lot of plastic injection machines, right? So you have some machines and they put robots on them instead of having people, right? So they can be unloaded automatically by these overhead gantry robots. And then, of course, new applications we're finding in manufacturing and small applications for collaborative robotics. And we're going to talk very specifically about what does that look like, right? So as I mentioned, in 1999, we had an updated published North American robot standard, the RIA 1506. Okay, that was the North American robot standard for North America. So it had, machinery builders, integrators, and the end user all encompassed. It was nice, and then it was I think it was reaffirmed in 2007, maybe wrong. I think that's when it was, and that a revision came up. And they looked at the 2011 version of this standard, right? This is ISO 12100. Now, this is the European then harmonized standard, right? And it covered the robot manufacturers and the integrators, because remember, that's our target audience in Europe, right? No end users. So they said, yeah. We want to have one global robot standard, close enough. So in 2012, North America, we adopted ISO 10218, 2011, parts 1 and part 2, right? And that became our new North American robot standard. So hey, now we're on the same boat. We adopted it. It was a national adoption. Boom, we are now following pretty much the same thing. The RIA, they published this as RIA 1506-2012. One problem. All the end user information that was in this original version is gone. No more guidance for North America just by that simple adoption. Because the rest of the stuff now is like, well, this isn't in ISO because we don't worry about that. So it disappeared. Okay, so in North America they said, ooh, okay, we got to put some of this stuff back, and we're going to talk about what does this look like putting this stuff back. Okay, it can't be part of the base standard, so they have to come out as technical reports. Okay, and so they've supplemented the base standards. So part 1 and part 2, manufacturers and obviously integrators are covered. A couple really interesting things came out of this. Because it's ISO, they use functional safety in Europe, right? ISO 13849 had already been documented and published. So they went from categories of EN 954 to ISO 13849, part 1 and part 2. This is the functional safety, this is performance levels. So how do I arrange my electrical circuits for the safety related part of the control system? This is functional safety. This is now a normative reference inside the North American robot standard. We now have, in this standard in North America, our first standard that says, oh, by the way, when you organize your safety-related control system for your robot, so your interlock guard switches, how you stop and control the robot, how you tie in your light curtains or scanners, ISO 13849, functional safety, this is now became our guide. Okay, that's new. That's new for North America, right? Collaborative operation, this is a new feature. Back in 2012, this was a new feature. 2011, this was a new feature. Because this safety-related requirement for the manufacturer of how they organize the safe motion control in a robot finally came, that technology finally got to the point where they said, we can now do some really interesting things. We can do safe motion control inside the robot controller. It's no longer just a kind of an open loop servo dumb system. So we've got some new things we can do there when it comes to collaboration, including the design of a collaborative robot. This is a very specific robot we're going to look at in a minute. And risk assessment, again, as I mentioned, is no longer optional. It is now mandatory, right? Because it's in the machinery directive. This is an ISO standard. You shall do a risk assessment. Not, that's a good idea. It would be nice to have, which was in the old standard. Now it's like, no, you gotta do one, right? So we are gonna do this. Now, when we have to come here and put back all this end user information, immediately they started developing the technical reports, right? So risk assessment, safeguarding, right? Change management, right? What do I do with older robot installations? What if I update this? What if I do that? That was a very interesting topic that the RIA had always helped end users with. I have a 10-year-old robot system. I'm going to retool it. I'm going to repurpose it. Okay, what part of the new standard am I grandfathered in versus what do I need to come in compliance with if I'm refurbishing or repurposing an old robot system, right? So there was guidance that they had to put back here, again, update and put. Really interesting. If you have older robots, that's a really interesting read for you.
Question on that one. Is there a complementary version of that in the machine builder section? Or since that is specific to robotic cells,
Right.
if you are now doing a
Actually,
line,
yeah. So the only other standard that really kind of covers this, most machine-specific standards will cover this inside the body of theirs. So if you take if you're doing general packaging machine, let's say, and it comes under the PMMI 155, if you go in and go look at that standard, it will tell you if you have an old machine and you're refurbishing it, when does this standard apply, when does it not apply, when can it be applied retroactively, when it can't.
okay.
NFPA 79 says the same thing for the electrical control system, which is actually the discussion I had with my counterpart yesterday.
I'm sure.
He says, well, if we're just upgrading the PLC, what else happens?
Yeah, exactly.
I'm like, well, if you go read NFPA 79, if you're remanufacturing a machine and modifying it and changing its functionality, then the new standard comes into compliance. But I also told them it's really your obligation to also inform your customer.
Sure.
Hey, I noticed these other 10 things are no longer in compliance with today's standards. You have either electrical short circuit requirements or arc flash or potential hazards of electrocution that are now covered in the new standard that this old cabinet is no longer compliant to.
Right.
And you might want to have us update those while we're changing out the PLC. This is our recommendation.
Sure.
If you choose not to do that, I want you to tell me don't do it.
Yeah.
This is your get out of jail free card, right?
Yeah.
This is like, no. I warned you, I told you should update this and you didn't, and that's okay, but this is on you.
Yeah.
Right? Because you touched it last.
Yeah.
Because this is
Yeah.
always the problem. When there is an issue and somebody gets hurt, let's say there's an arc flash or somebody gets electrocuted, like, well, who touched this last? Your company.
Right.
Well, I have it documented right here. I told you these things weren't in compliance and you should have fixed these, and you told me no. Your your attorney will love this document.
Okay. Because we've done stuff, well, it's not always the electrical stuff, often it's also, machines built in the 60s.
Aren't safe.
Are not,
Okay.
oh, you gotta stick your hand in here to do this.
Now that is
thing, down.
absolutely then, you elevate the discussion even more. Because it's no longer about changing the PLC.
Right.
It's about bringing the machine into compliance with safety requirements.
Sure, and I know we've had multiple customers that we essentially had turned down because this really needs to be fixed. Well, what if we write you a document saying we're okay with it? Like, not sure where that falls, right?
No, that is your get out of jail free card.
Yeah.
You've offered to make it better. You've
Mhm.
offered to do an assessment and document it and show them what it would take to come into compliance.
Right.
And if they, again, turn you down, you say, okay, that's your prerogative, I won't do that work, but I have a document that says, I told you and you chose
Right.
not to anyway.
Okay.
That will squash a lot
Okay.
of a lot of legal issues later.
Gotcha.
Right? And I know that from a fact because I've actually experienced that a couple of times.
Okay.
Where customers have said, no, we get it, we'll take care of it. 2
Okay.
years later, you get a call, there's been an accident, and you're like, nobody took care of it.
Yeah.
And someone got hurt. And they said, well, yeah, it's your fault. Because you, like, no, I have a document here that said I offered to do this, and you said, we'll take care of it.
Okay.
And I have that in writing, right? And
Gotcha.
all of a sudden, okay, fine.
Okay.
Click, right?
Yeah.
So, yeah, absolutely. So collaborative robots. Our RIA 15.606 then was also a national adoption of ISO 15.066, and we're going to look at that one specifically coming up here because this is the additional information of how to do power and force limiting and how to apply collaborative applications properly. And this was something that was augmented even in Europe because the base standards didn't really cover the details of that well. Now we're going to circle back to one other standard I wanted to talk about when we got to the robot section, which is B1120, harmonized with ISO 11161. This is integrated manufacturing, right? These standards say very much the same thing. About 75% of all robot cells get complex enough that they become an integrated manufacturing system. If you have a simple weld cell or something very simple where it's like a robot and a fixture and maybe there's a manual tender putting parts in or something fairly simple, probably not. But as soon as you get a robot cell that has 3 or 4 robots and 2 or 3 other machines and a bunch of material handling equipment, this becomes an integrated manufacturing system. As a matter of fact, that's the definition of an integrated manufacturing system. At least one robot, at least one other machine connected with some material handling equipment with a coordinated control system, right, that keeps those things integrated together properly. But yet I can still go in and teach the robot separately. I can still go in and run this machine separately, right? This was designed by somebody else. So it looks like this, right? So we know we have a robot. When the robot's manufactured, the robot manufacturer says, I have no idea how you're going to use this, so I worry about me, okay? And then you say, well, I'm the integrator, and I'm going to put this cell together so it expands a little bit more, and I have standards, obviously, that are harmonized, but then I have other C-type machines. So now I have a CNC, or I have some other piece of equipment, right, that has its own standard. And again, that manufacturer said, well, I didn't know you were going to put it in a robot cell. I've got e-stops and I've got all the safeties on this machine all tied into it properly for this use. And you've decided that this door comes off and this circuit changes and you're going to drop it into a robot cell and you're going to integrate it into a coordinated control so it can be tended or run completely different by the robot. Okay, this gets a little complex. Now who owns the span of control of this safety device? What if I walk through this door? Does that need to stop? Right? I don't know. You're going to need to do a very complex risk assessment. And as a matter of fact, B1120 and ISO 11161 does exactly that. It's called layout analysis. And it is dovetailed with the risk assessment to understand this complex interaction of these pieces of equipment that have now been connected together, right? we did a really nice system, a risk assessment, and supported a customer of ours who was building a robot cell that manufactured EV car batteries. Okay, the cell is 8 of these rooms put together, 27 robots, 4 zones, material handling equipment and other pieces of custom built machines to do either the testing or x-ray or whatever, all in one big cell. Definitely the definition of an integrated manufacturing system. Unbelievably complex. If I walk through that door, that machine down there doesn't stop. And if I walk in through that door, then that machine does have to stop. But these robots don't have to stop, right? If I do walk through this door, there's an internal light curtain that has to turn on because now I have to take this zone and separate it from that zone because I want to keep that zone moving. But I only want to worry about these 2 robots that are bringing material in, right, and doing the first processes, okay? But I need to make sure people don't start walking down through the cell. I need to capture that. So I don't need this light curtain on any other time unless they come in here or they come in here, right? So span of control and understanding, what this light curtain is doing, right? And what it's protecting, very important. So these standards help you understand these complex
Would
situations.
something as simple as just like a one robot to one machine, like a machine tending operation?
Then you'll find everything in part 2
Okay.
of ISO, either 10218 or R1506, right? Should be able to do everything there, but again, it gets this complex and you need this type of
Okay. That's where
support.
the line is from.
This is where layout analysis comes in, right? One robot, at least one other machine, and material handling connectivity with a centralized control. If you don't have that, then you really don't have an integrated manufacturing system. So you could probably do it without it. Okay. So yeah, this is what they look like. It's coordinated control, but yet I can still go in and operate maybe an individual piece of equipment, either manually or set it up or operate it in a way that the manufacturer had intended. But I still need to make sure that that can be done safely if it needs to be done, independently of the coordinated control. So that's where the standard will help you with that.
Is it better to have a third-party risk assessment come in and look at something like that, or?
Not necessarily. It is totally up to your organization and your skill set, right? We have companies, we work with integrators, robot integrators, who will have us do a risk assessment and train them on how to do it because they would like to do that on a regular basis as they do their own systems. And so we support them in that. But we have some end users like, that's not our expertise, we don't want to do that. No, we're just going to hire you to do it, right? So it's going to depend on what your needs are, right?
Yeah.
But we do that all the time for our customers. We'll do a lot of end user assessments, we'll do some integrator, and then we'll do some training. And teach both how to do it themselves depending on their.
So responsibility for accidents fall on you if you're a third party doing the risk assessment?
Well, we'll certainly be, drug into it if something goes wrong. That's why we have a very, very high level of safety plan. All of our functional safety engineers who do our assessments and our safe design for customers are certified, and we have an unbelievably rigorous safety plan. We have reviews, and we have, because we do take on liability when we do projects for customers, for sure. So we do that. So real quick, let's take a look at terminology. And this was updated to come in line, so everybody's taught when we talk about space, right? We're no longer talking about envelopes, we're talking about space. So we have the maximum space of the robot right out of the box. This is the complete area a robot can move. Restricted space, then we need to kind of zero the robot's movement into just what's necessary, right? Quite often customers will say, well, I don't need this big footprint, I'm only doing something small. Well, it used to be you'd put mechanical hard stops on the robot axis to keep the robot, from going crazy. Now this can be safety rated, right? We've got that new safe motion control on the robot. So FANUC calls it DCS, ABB calls it Safe Move, Yaskawa, I heard, calls it Functional Safety System.
FSU, right?
Yeah, FSU, yeah. That system, does this real-time like oversight of the robots not exceeding this restricted area I've told it to stay in, right? And therefore I can keep my clearances to my perimeter safeguarding, whether that's a fence, whether that's a light curtain, whether that's a 2D LiDAR, right? We can't exceed. So the safeguarded space, right? The operational space, the safeguarded space has to be outside of that restricted space. So we can't operate, we don't want to operate outside. We don't want to hit the fence, we don't want to hit the wall, right? We don't want to bump through a light curtain, right? Whatever we've defined our perimeter of our safeguarded space, right? We don't want to go through that. So we want to keep that inside. And then the actual program in this operating space will be the smallest subset of that. And we'll take a look, there's one more smaller subset of that space, right? But this is the program task here then for the robot. So whenever you're talking about the space, these are the requirements and how the space is organized, right? Now one last thing, in that when we are doing collaborative applications, and we're going to talk a little bit about that in a second, when we do collaborative applications, there are purposely designed collaborative robots. That doesn't mean you can't do a collaborative application with a standard industrial robot. That's okay, right? And there's only a couple of those that you can do. You can only do true collaboration with a collaborative robot, because a collaborative robot is designed specifically to come in contact with a human. Okay? They are designed to operate, right, and collaborate together in the defined collaborative workspace. Okay? This collaborative workspace is within the safeguarded space and the operating space of the robot. So the robot may be swinging over here to do something, but I'm standing over here, and during my risk assessment, I'm going to identify the potential interactions with the person and the robot. These are the ones that are going to become important, as I'm going to show you when we implement power and force limiting. This is one method of doing collaboration. That when that happens, we have some new special rules that kick in about the power and force. We're going to look at that. And when I do that, then this is a subset of the operating space, okay? So collaborative operation, let's take a look at these 4 different operations. So, as I mentioned, ISO 15006, this was a technical specification, so this was also additive to the base standard, to ISO 10218. This was robots and robotic devices, collaborative robots. So this gave us very specific details about how to do collaboration in the 4 methods, including the requirements for power and force limiting, right, with interaction with the human, and more specifically, forces on the human body. So this was then adopted, as I mentioned earlier, by the RIA as TR 15.606, right? It's a full-on North America adoption. So in there, it states there are 4 methods, as I mentioned, of collaboration, collaborative operation. So safety-rated monitored stop. We have this new safety-rated motion system now in the robot controller. So using a presence sensing device, I can approach the robot and be detected. The robot can slow down and then come to a stop and hold position. And if I leave and I'm continuously detected and I don't find my way into the safeguarded space and get lost, right? The control system can keep track of me, and when I leave, it can restart. That's the way this robot out here is oriented. If you walk up to it, it turns red and it goes click, and the robot stops. It is now in safety-rated monitored stop, and as soon as you walk away, the scanner says, person's gone, you may restart. But if I walk around the back and I go outside of that space, it clicks out, now you need to reset and restart because it lost track of you, okay? So this is a new collaborative feature. So I can go in and do something, come out, go in, come out, go in, come out, right? As long as everything's nice, that works great.
Question, is that strictly on the collaborative robots?
No, you can do that with industrial robots. Okay. Yep. Same thing with speed and separation monitoring, speed and distance monitoring. Now the unique thing about this is that the robot slows down as you get closer. So 2D LiDAR gives us the ability to have several safety fields that will slow down the robot as you keep getting closer. Now, application-based, right? So let's say I need to come over here, but the robot's over there, and occasionally I come in here and I do something. The robot says, okay, you got a little close to me, so I'm just gonna slow down and keep this distance between you and me to the point where I can stop quick enough if you decide to come over, okay? So as you get closer to me, eventually you'll get too close to me and I'll go to here. And now in this whole position, and then as you walk away, I'm like, okay, go back again, okay, now I can go a little faster, a little bit, until you walk away, okay? So here is an application where you can become a little bit more productive. It's not just binary on and off, it's different levels of speed until you get to on and off, okay?
You want to see that, that's next door.
That's next door.
25 is set up exactly that way.
Okay, right. I've seen it, I just haven't seen it done with industrial robots. Normally it's the
No,
collaborative ones.
these are methods of collaboration that have nothing to do with this type of robot. Okay. Now, hand guiding's been done for a long time. There are a lot of requirements. You have to have the 3-position enabling switch. You have to select the mode. The safety rated motion controller of the robot keeps track of how fast it's going. It can't exceed a certain limit, right? And then this can be done very simply. So I do have connection to the robot with the human. They are interacting in the same space at the same time. These are cooperative, not simultaneous activity at the same time. And then the one we're all interested in, power and force limiting. This is simultaneous activity in the same space at the same time, right? This is coexistence, okay? So therefore, this is where we need to ensure that those, again, expected collaborations for the operator or coming in contact with the robot is handled by this power and force limiting that's outlined in the standard, right? This is a specifically designed robot, designed with smooth edges, and no pinch points, right? Because I expect the person to come in contact with this robot. So I have some new rules, some new things. The major thing that this document, this technical specification provided us with is this information about when it does hit you, or hits your arm, or it comes down and happens to push on the hand, right? How much force and pressure is allowable to that part of your body, okay? So this document, they conducted a test at the university, or an experiment, if you will, and actually put 100 people through a specially designed machine to poke and prod on all the different parts of the body until they took the data from all the people who were tested and said, how much force does it take pressing on the back of your hand until you say ouch? Until it's the onset of pain, right? Or or potential injury, okay? That information then was transferred into, is it quasi-static, right? Is it a quasi-static? Or is it, the actual force in a transient, right? If I get hit and my arm bounces away versus my arm's up against something, can I get hit and I keep pressing? Okay, those are two different values I need to know. Okay, so I need to know the initial impact and then the ongoing force that's applied to that part of the body. So this is where this information was then published, and they said, okay, these are the limits. Okay, so during my risk assessment, I decided that while I'm here, the robot may come down and hit my hand, this collaborative robot. Okay, so then I come back to here and I say, back in the hand, okay, and I have values for both the transient and force for the quasi-static. Okay, so now I need to know, set up the robot to make sure during this move, I don't exceed this. This is where people who design these types of systems find out all of a sudden, I can't do what I wanted to do with the robot because I didn't know this, and I need more force than that. Or maybe during this move, I need higher speed because I've already calculated my ROI on attack time, and all of a sudden my collaborative robot system I thought was good. And I do this, and I can't do this. I can't achieve some, maybe I can hit some of these, but some of these I can't, okay? So all I'm gonna do is slow down the robot, so it has less inertia in the movement, right? Based on the payload, based on how much force I need, right? You can make the robot stop, but you might not get done what you need to get done with the robot. So this is the wake-up call to a lot of people, like, oh yeah, I didn't realize that, right? So we're gonna come back to this in a minute. So how do I know this? And we'll take a look at the next technical report, then that lets you know, the next couple of technical reports will let you know, well, how do I know I have too much force, right? So TRA 15706, this was a technical report that helps the end user understand what methodology of collaboration would work best for my application. Ask enough questions. Do I need to be there at the same time the robot's moving, yes or no? If the answer is no, then you have other options. You can do speed and separation monitoring, right? You can get higher productivity, even though you do have to be in there sometimes. Maybe power force limiting won't work for you, and that's okay. But you can do these collaborative applications and still gain productivity with or without a collaborative robot, right? Those things are, but if I do actually have human contact simultaneous, then we know that power force limiting is the only way to do that, okay? Now, as I mentioned, we need a methodology then to know when the force is enough. So there's this measuring tool that we use, and we actually go out and measure the force, right? So I can set the robot controller at a certain speed and say, okay, well, don't go more than 100 millimeters per second during this move. I want to slow it down because this is the one where it may hit my arm, okay? So it picks up the object, and as it's moving with that mass now, I need to measure that. Because maybe 100 millimeters per second is still too fast, and the inertia of the mass as it swings it over hits me in the shoulder and exceeds that chart. So I have to keep running that number down until I get it. And I have to measure it because just setting the speed in the robot's like, okay, well, whatever, when you exceed the force, I'll trip out. Well, exceeding the force isn't the measurement of the force that you felt. It's the measure of the force that went down through the control system that said, oh, I just tripped out and went over, 120 newtons. Yeah, but I saw 210 newtons on my arm by the time you saw 120 newtons in the control system, okay? So it needs to be verified, it needs to be validated. So we have this tool, we will take these measurements. We do this as a service for our customers. And they say, okay, here's my collaborative application. I've identified in my risk assessment, these are the 3 moves that I'm concerned about that may come in contact with these different parts of the operator. Let's measure those and make sure we've got this set up properly. Okay, this is the sequence. Okay, so this document here, 15.806, gives you the guidance on how to do this and how to document it, right, and how to, validate your solution. Okay. Any questions? I know it's really fast and we're a little behind and I got to finish up with the mobile robotics, but any questions? Okay. All right, last but not least, mobile robotics, right? So the RIA, had the fixed application, fixed industrial robot standards. The International Truck Standard Development Foundation had B56.5. These are for AGVs, right? These are guided vehicles, okay? So we had these 2 standards, but what was happening is people said, well, we're going to start creating robots that are mobile, and they're not guided, they're autonomous, and sometimes we bolt stuff on the top of them that look like robots, and sometimes it's racking, and sometimes it's conveyors, right? They have other attachments, and we didn't have a standard for that. So the RIA set out to develop this R1508, okay? So the first thing they said, well, what's in scope, what's out of scope? So the quickest way to understand what's in scope, first of all, it has to be an industrial application. This is not for the little robots that are running around your Walmart that are cleaning the floor. That's a public space, okay? Those people are not employees. They're not trained. They don't know anything about this thing, right? So the application of this standard is only for industrial applications. There's another standard for self-care robots and other types of robots that fall into the public space. but this is for the industrial application. So if you don't have an industrial application where you only have employees exposed that are under your employment, this is not for you. Is it a mobile platform? If it's not a mobile platform, then it's probably a robot, and we have a standard for robots, right? And that is the North American Robot Standard. We just talked about that. What is the navigation? Well, if it's manual, right, that's out. We're not talking about manual. In other words, if I take a robot and I just put it on a cart and I move it around and set it down, because people do that. They'll make their robots, they can run them around. We have customers who put collaborative robots on a cart and then move them to different machines with the same program to do the same machine tending, let's say. That's not what we're talking about either. That's still covered by the industrial robot standard, right? However, if we have a guided platform, now we're talking about a mobile platform that is guided in nature, then it's an AGV, okay? Regardless of the attachment type, right? This is a driverless industrial truck, falls under the AGV standard. This is the B56.5, okay? That is that. If it has other type of attachment on top of it, this is still same standard because it's guided, okay? The restriction is that it's guided. It doesn't lead the guided path. As a matter of fact, the standard says that it leads the guided path. More than X dimension, stop the vehicle. And the vehicle sits there, it detects objects, and it doesn't move until the object's gone. Doesn't replan its route, doesn't think for itself, doesn't find a new way through the facility. It sits there and says, nope, this is my path. If it's not clear, I don't move. Okay, it's an AGV. However, if your navigation is one of these new-fangled autonomous vehicles where it can path plan, it can re-navigate according to external information or its own object detection information, so it may use SLAM, localization and mapping, and say, oh, I have a map of the area, I know that that's a new obstacle, can I get around it, can I take another aisle, can I get to my point B through another way, right? This is an autonomous mobile robot, okay? And if it has no attachment, meaning it's just a mobile platform, base platform, this is a type A. The standard says that's a type A industrial mobile robot. If it has some other attachment, like racking, fork truck, lift, or conveyor, this is a type B attachment, and this is a type B IMR, okay? Different risks now have been now added to the mobile platform that are handled in another part of the standard. And if I decide I'm going to put a robot on the top and put a multi-axis manipulator on it, this is a type C AMR. Okay, the standard then calls all three of those into scope. And as well as, if I have an AGV that also happens to have a multi-purpose manipulator attached to the top, we will also cover that under the scope of this. This is the only place that AGV actually is covered as a type C. Okay, so that's also within scope, even if it's guided. It just has to have a robot on top, okay? Because it's still a mobile robot, okay, in essence, all right? So that's your mobile platforms that we're considering and we're concerned about. This standard covers those in the scope. Part 1 has been released. Part 1 is only for manufacturers, okay? So only manufacturers, suppliers, OEMs. This was published last year. Contains all the requirements for A, B, and C type attachments, right? That is approved and is published, okay? What is in process now is part 2. This is from the system integrator. So now I take these and I put them into a facility and I deploy a fleet. So now the fleet has to be managed. There might be new interactions with either multiple IMRs, people in IMRs, racking, picking. Now we have new hazards we have to concern ourselves with as an integrator. These are now for you to figure out. So that standard will help with that as we deploy these into facilities. Okay, this is ongoing. This is going to take a while. Hopefully by the end of next year, this standard will be published. Okay, and then also, obviously, because that's part 1 and part 2, that also could look to the ISO adoption is a future path for machine builders and integrators. However, for North America, we know that we're gonna need part 3. This is requirements for end users, right? This is our problem, or our focus, if you will. Hasn't even been announced, but it'll soon be under development, okay?
So when you're talking about guided, where does this guided standard pick up in like a 7th axis mobile within a cell or gantry? Where's the dividing line? Like what's?
Well, this is for a mobile platform. So mobile
Okay.
platform, you know, if you put a gantry, a multi-axis manipulator on top of a mobile platform, it's mobile platform, it's a Type C.
Well, I'm thinking a robot arm on a gantry.
That is covered under
That's all
1506.
Okay.
1506 covers the 7th axis, which is,
Yeah.
again, it's not mobile. It doesn't navigate, move around. It's on a gantry, so it's fixed. It's just on a gantry, right? That's the one
A
you're.
gantry or a track
It's
or.
mobile, but it's a fixed
Within
area
the cell.
with it
Yeah.
where it is.
It's
Okay.
fixed, yeah. So, real quick, I'll go through, I wanted to talk to you about one last thing, I know we're a little over on time. So, this device here, this is becoming very prevalent, we're helping a lot of customers with this device. There was a little bit of concern between the truck standard foundation and the new mobile robot standard, so right at the end, they took a couple things out of the scope of the standard, okay? And we have some customers who are stuck in no man's land in this gray area between these two standards, because people are taking these stand-up, sit-on driver fork trucks and making driverless and automating them and making them autonomous. And specifically, those have been carved out of the scope, right? Same as anything that lifts loads and pallets, i.e. fork trucks. So basically, any type of fork truck, right? The fork truck development standard said, no, industrial fork truck. I don't care if it's autonomous. It's not in scope of your standard. And so even though this was carved out, we still recommend to our customers, this is state of the art. If you have an autonomous vehicle, so if it looks like a duck or quacks like a duck, this is still the duck standard. Still, this is your best bet, right? Regardless of the argument and the political wrangling, it's not your best, your best information is here, okay? So yes, it's fine. And we have a lot of customers who say, yeah, we get that, and we agree. So that's how we're applying it. So with that, we'll end. Any further questions? I know I went through the last bit a little bit quick, apologize for that.
I've got something on the integrated manufacturing cell or system. So when you have multiple zones that you're stopping in, essentially are you creating a risk assessment for each zone and then applying that specific sill level to that zone of the cell? Or does the entire cell have to have the same sill level regardless of the actions?
Great question, and that's exactly why you do a risk assessment, right? Because if I have tasks over in this part of the cell, and I'm only exposed to the clamping mechanism, that's lower risk
Yeah.
than if I'm exposed to the huge robot over here that will crush me.
Right.
Okay, so when I go over in here, the risk is higher than when I come in over here.
Okay.
So my circuit design and everything I do, I have a different look at, and my requirements are going to be slightly different.
Sure.
Even if I do have some higher risk things here, if I walk in and I shut those off, shutting off the lower risk items and control items, and as a control person, you'll get this really quick, that can become expensive if I have to do it all at the highest level.
Right.
If I can start splitting up the levels, I can shut off some of these other things with less money.
Yeah.
and less stuff, right?
Sure.
And that's exactly why you do the risk assessment, to start sorting this out and saying, this is low risk, these tasks, I'm only exposed to that here, this is enough, but over here, this is a little worse, this is enough,
Good.
okay? So absolutely, that's the benefit of doing the assessment.
Okay.
Otherwise, you paint everything with a broad brush,
Right.
weakest link, right, or the highest requirement becomes the only requirement.
Right.
And then that can get expensive, and
Sure.
it leads to over-engineering. This is not what you want to
Okay. Perfect. Thank you.
do. Yep. Okay, if not, well, thank you, everybody, I appreciate it.
Thank you, Mark.
Have a good day.